Philosophy of Science. Francis Bacon was right. The present-day linguistic philosophy is essentially a continuation, though in changed circumstances, of the tradition of British empiricism founded by Locke, Berkeley and Hume, and indeed, these philosophers all acknowledge their debt, to Hume in particular. But in the 200 years since Hume a great deal has happened. The sequence of thought which has been reviewed, from Bacon to Hume, took place on the basis of the bourgeois revolution in Britain and the primitive accumulation of capital. Then came the great social transformation wrought by the Industrial Revolution, which was made possible by, and carried along in its train, the tremendous development of the natural sciences. Germane to our present theme are those philosophers who directly adapted the heritage of Locke, Berkeley and Hume to the new conditions of industrial capitalism and the new discoveries of the sciences. These discoveries amply bore out what Francis Bacon asserted at the beginning of his Novum Organum: man does and understands as much as his observations permit him, and neither knows nor is capable of more. What with Bacon had been a bold stroke of imagination became almost a truism, borne out by the most abundant experience. While philosophers sat speculating and deducing from first principles how the universe was and must be constituted, and what laws all things in it must obey, scientists got to work with their techniques of experiment and observation, and began to find out what processes really take place in nature, how they work and how they can be used. The whole epoch of great foundation discoveries by the natural sciences during the 19th century was prolific of philosophical speculations and philosophical systems of all sorts. But the advance of the sciences was putting these in the shade, and furnishing an ever more effective demonstration that what men cannot know about nature and society, by following the empirical methods of science, they cannot know at all. The science of the 17th and 18th centuries had been mainly mechanistic, that is to say, it had assumed that nature was rather like a machine, made of fixed parts which moved and interacted according to unchangeable laws, continually repeating the same movements and producing the same results. The great discoveries of the Industrial Revolution, on the other hand, are mostly concerned with the transformations and processes of evolution and development which take place in nature. As a result, the conception of nature was revolutionized. Instead of the same motions endlessly repeated, there emerged the picture of one form of motion being transformed into another, and of change, development and evolution taking place everywhere. Discoveries in thermodynamics, for example, showed how different energies are transformed into one another, as in the steam engine heat is transformed into mechanical motion. Faraday showed how electrical forces are generated by a moving magnet. The investigation of living organisms showed how all forms of life are developed from cells. The Darwinian theory showed how all living species had evolved by natural selection from more primitive forms. Geology showed how the Earth itself changed, and astronomy that the stars are not unchanging too. Dialectical materialism. In this way the sciences began to present a picture of the material world, in which everything could be explained from the material world itself, in terms of processes of the transformation and development of material systems. A living cell is a chemical system, and the original forms of life themselves came into being by the formation of complex molecules. Man himself evolved by natural selection from among the primates. It remained to work out how human society and human consciousness could have evolved from natural rather than from supernatural causes, and this was done by the hypothesis of historical materialism, put forward by Marx at about the same time as Darwin was working out the theory of evolution by natural selection. This was a hypothesis comparable with those advanced in other fields of fundamental theory in the sciences. Marx showed that what differentiated man from other animals was his way of using tools to produce his means of life. Men thus created social forces of production, corresponding to the development of which they entered into relations of production, and corresponding to those relations of production, they created social institutions and the whole complex of conscious social life. As Engels put it, just as Darwin discovered the law of development of organic nature, so Marx discovered the law of development of human history. Speech at Marx's graveside. The philosophy of dialectical materialism, put forward by Marx and Engels, was based on accepting the fundamental principle that we can know only so much as we can discover by empirical procedures. All a priori principles, all alleged certainties founded on anything other than observation and the verification of theories by practice, were ruled out. But this was far from meaning that our knowledge is limited to our own sense impressions. On the contrary, Human knowledge is capable of penetrating further and further into the constitution, causes and laws of material processes which take place independently of our perceiving or knowing them. Being is prior to thinking. The object exists independently of its being perceived or thought about, and all the phenomena of consciousness are to be explained as the reflected end result of material processes, not the other way about. Adopting this strictly materialist standpoint, Marx and Engels at the same time rejected the mechanistic assumptions of earlier materialist philosophies. The world was to be understood, not as a complex of things, but as a complex of processes, in which apparently stable things, together with their reflections in our consciousness, go through an unending succession of coming into being and ceasing to be, of change and development. Motion is the mode of existence of matter, but the motion of matter cannot be reduced to one fundamental mode of mechanical interaction. Simple spatial displacement and mechanical interaction, chemical change, life, and human conscious activity are so many evolving forms of material motion, in which the higher always presupposes the lower, but cannot be reduced to it. The task of scientific inquiry is always to discover the laws of motion in terms of which particular phenomena can be explained and brought within the scope of human prediction or control. This means understanding Ws in their motion and change, and in their complex interconnections, understanding the ways in which purely quantitative changes result in qualitative changes, and unraveling the tangle of contradictory relationships between and within processes by the working out of which all real change and development takes place. This philosophy represented a summary and generalization of the methods and discoveries of the natural sciences. As Engels insisted, it was not a philosophy which attempted to impose itself on the sciences, but it was drawn from them. As such, its tendency was to liberate the sciences from pre-scientific philosophical or theological doctrines, as well as from the hangover of the earlier purely mechanistic assumptions of the sciences themselves, and it served as the guiding light for the further application of scientific methods in formulating the fundamental theory of the development of human society and human consciousness. 3. The analysis of sensations. By contrast, right throughout the 19th and well into the 20th centuries there continued to be asserted what had then become the classical doctrine of empiricism, namely, that sense impressions are the objects of knowledge, and that knowledge cannot be concerned with an external material world. A succession of philosophers, not noted individually for any special originality, verve or consistency, but taken altogether producing a quite impressive body of theory, took it upon themselves to philosophize about and interpret the natural sciences in this fashion. They all tried to assimilate the great scientific discoveries of the age of industrial capitalism, while maintaining that scientific knowledge extends no further than the limits of one's own sense impressions. The emphasis which Hume had formerly placed on the skeptical implications of this doctrine came to be changed. Hume's whole emphasis, as we have seen, was laid on the lack of any positive foundation for human knowledge. But the subsequent development of scientific discovery and technology was so impressive that the bland skepticism of Hume seemed out of place. His successors sought to interpret the methods of the empirical sciences as methods of acquiring positive knowledge, and the chief problem which engaged their attention was that of interpreting scientific discovery. The resulting philosophy of science, in all its variations, may be conveniently labeled positivism. In Britain, J.S. Cap 1 elaborated what was called inductive logic, and formulated what he considered to be the reliable scientific methods for inferring from particular data of observation universal conclusions about the order and sequence of events. According to him, and to Carl Pearson, of T.H. Huxley and others, who adopted the same point of view, what the sciences achieve is the methodical prediction of the ordering of sense impressions. They explain that when science refers to material objects and material causes, what it actually does is predict what groupings and sequences of sensations to expect. A material object, as J.S. Mill put it, is a permanent possibility of sensation. This contention proved capable of elaboration in two divergent ways. One way, which I need not discuss further, since it has little relevance to my theme, was proposed in the United States by Charles Peirce, and led to the peculiarly American brand of positivist philosophy known as pragmatism, instrumentalism or operationalism. Peirce suggested that what we mean when we talk about objects should not be construed as simply a prediction of sensations, but rather as a prediction of the results of action. For sensations are not merely passively received, but are obtained in the course of human activity. Significant statements are like programs of action, and those which serve no such practical purpose are virtually meaningless. This led to a new definition of truth. What makes a statement true is not the fact that objects are actually related in the way the statement says they are. What makes it true is the success of the action which we take in conformity with it. The other way consisted in trying to state explicitly what is really the case, or what really exists, corresponding to statements vouched for by scientific methods of inquiry. Taking it for granted that knowledge is limited to sense impressions, it was concluded that the real elements of the world, the constitutive atoms out of which all things are built up, as in the ancient atomic philosophy of Democritus and Epicurus, are nothing but sensations. Perhaps a simplest and least ambiguous statement of this conclusion was that contained in Ernst Mach's book, The Analysis of Sensations. Bodies do not produce sensations, but complexes of elements, complexes of sensations, make up bodies, Mach announced. If to the physicist, bodies appear the real, abiding existences, whilst the elements are regarded merely as their evanescent, transitory appearance, the physicist forgets, in the Asamphibhophi USB view, that all bodies are but thought, symbols for complexes of elements, complexes of sensations. Having said that, Mach proceeded to dispose of the view, first foreshadowed by Locke, and afterwards stated by Kant, that causing our sensations there exist things in themselves, the nature of which cannot be known. For us, he said, the world does not consist of mysterious entities, which by their interaction with another, equally mysterious entity, the ego, produce sensations, which alone are accessible. For us colors, sounds, spaces, times, are provisionally the ultimate elements, whose given condition it is our business to investigate. It is precisely in this that the exploration of reality consists. Although Mach stuck in the word provisionally in deference to scientific caution, as a physicist might have said that provisionally atoms were to be regarded as the ultimate constituents of matter, until such time as later techniques might succeed in splitting the atom, it is pretty obvious that he saw no prospects of ever reducing sensations to anything other than sensations. The word provisionally was, indeed, quite out of place in his exposition. Mach proceeded to argue that his analysis in no way represented a subjectivist or idealist point of view. He was not saying, as Berkeley had done, that reality was in essence mental or spiritual, as opposed to material. On the contrary, the antithesis between ego and world, between sensation, appearance and thing, vanishes, and we have simply to deal with the connection of the elements. The elements, he explained, are not mental, but neither are they material. They are, as he put it, neutral. And in this way he ingeniously explained the connection between the physical sciences and psychology. When we deal with one sort of order of the elements, that is the science of psychology, and we call them mental. When we deal with another sort of order, that is the science of physics, and we call them physical or material. But really they are neutral, just elements, and all our knowledge and all science has the same objects, namely, the elements with which we are acquainted in experience, and which in one order make up a mind, and in another order a body. For a misfit, all the various positivist schemes for justifying the methods of science and interpreting its discoveries assumed that what science achieves is the prediction of experience, and that the method of science is the method of reaching universal conclusions from particular data. The scientist, in other words, observes certain connections within his experience, whether these are termed combinations of sensation or experienced consequences of activity, and then formulates his scientific conclusion in the form of a law. This law is, in effect, a formula for predicting future experience, namely, that the elements of experience will always be connected in accordance with the law. So long as experience continues to verify the prediction, the law is all right, but if future experience contains anything which does not accord with the prediction, then the formulation of the law must be altered so as to accord with experience. Of course, the laws formulated by the sciences need not all be of the same form, and a good deal of attention was given by the philosophers of science to sorting out the various different forms of scientific law. For example, there are laws of the simplest form, which simply say that A is invariably combined with or followed by B. There are more complicated laws, of the sort which J.S. Mill called concomitant variation, which say that A varies with B, or express A as a function of B, and there are also statistical laws, which do not say that a certain sequence invariably occurs but state the frequencies with which different sequences occur. This study of the form of laws lent to the positivist philosophy of science a certain plausibility. Physics has often been held to be, in some sense, the most fundamental or universal of the natural sciences, and as physics advanced, especially at and after the turn of the century, this philosophy was able to supply a very simple interpretation of physical laws. Physics came to be regarded as the model science, and other sciences as scientific insofar as they approximated to standards set by physics. The fundamental laws of physics express the dependence of one quantity on another, where these are measurable by readings from physical apparatus. The laws of physics, then, are represented simply as generalizations, largely statistical, and expressed as mathematical formulas, coordinating such readings. As A.S. Eddington later put it, the subject matter of physics consists of pointers and gs, flashes on screens and similar indications the nature of the physical world. These elements of experience, and nothing else, were said to be the subject matter of physical science. When the physicist talks of atomos, electrons, and so on, he is merely using convenient, though somewhat misleading expressions for the formulation of complicated laws coordinating data given in experience. He is not discovering anything about the constitution of the material world, which exists independent of his experience. The plausibility of this interpretation of the procedures and findings of the physical sciences depends on two conditions. First, that attention is confined to how sciences draw conclusions from observational data, and no attention paid to how the observational data themselves are obtained, and second, that the conclusions of the sciences are taken to consist of laws which enable future events to be predicted. The work of the theoretical physicist, it is true, begins with the data which are presented to him. His job is to devise formulas which will fit all the data. But where do these data come from? They are readings of various kinds of apparatus, and the apparatus must first be devised and constructed in order to get the data. The science of physics does not in fact start from pointer readings and similar indications. On the contrary, such data are a product of scientific work and not its commencing point. Modern natural science, whether one considers physics or any other of its branches, is not an undertaking for devising formulas to fit given data, but is a major cooperative undertaking for devising research techniques. The theoretical physicist may be content to accept the data that are given to him and use them as the starting point for his theories, but that is only because he knows and is satisfied with the techniques by which they were obtained. And if he did not know those techniques, he would not know how to construct his theories or formulate the laws of physics. Thus, for instance, there are various sorts of pointer readings, taken from scales, clocks, galvanometers, etc. The pointer is, of course, a part of a physical object, namely, a scientific instrument, which was very carefully constructed and tested according to certain established rules in order to register certain changes by measurement on a scale. The pointer reading is not a datum but something obtained by definite means for a definite purpose, namely, the purpose of finding out more about physical processes than is revealed by crude observation, unaided by special techniques. All natural sciences depend on specialized research techniques, adapted to the particular subject matter. The techniques consist of cooperative activity, interposed between the senses and the object, with the purpose of more thoroughly exploring the properties of the object. People devise means of acting on external objects, and making those objects produce their effects, in order by that means, as Francis Bacon explained long ago, to know more about those objects and to be able to do more with them. And that being so, it does not fit the facts to interpret physics, or any other of the natural sciences, as though the subject matter were confined to the observational data given in experience such as the pointer readings. In the case of physics, nor did the pragmatism or operationalism prove the fit by making the subject matter the operations performed by experimenters. On the contrary, scientific theory is founded, not just on given data, or records of operations, but on the cooperative purpose of activity of producing changes in external objects, together with the construction of means to register and record those changes, and the subject matter of scientific research is, accordingly, not just the observational data, the end record, but the constitution, properties and laws of the objects of the research activity. If, then, we consider the content of the conclusions of the sciences, or of scientific theories, it is also evident that these cannot be interpreted simply as formulas for predicting future experiences. On the contrary, since the sciences engage in practical exploration of the objective material world, their discoveries concern the constituents of that world, the forms of motion and interconnection, the interdependencies of material structures, the emergence of more complex structures with novel properties from simpler ones, and the processes of transformation and development by which what exists at one time came into being out of what existed at an earlier time. And the outcome is not only ability to predict experience, but a practical mastery over those processes themselves. According to Mill's inductive logic, the sciences are based on procedures of arguing from the particular to the general, from particular connections, several times observed, to a universal law. Although it came to be recognized that Mill's methods were far from affording a satisfactory account of the processes of scientific reasoning, nevertheless it continued to be assumed that the sciences proceed by induction, that is, by extrapolating laws from observed instances. Hume had pointed out that there are no known principles of logic to justify any such procedure, nor have any such principles been discovered since. And yet it continued to assume that this is the basic or essential procedure of the sciences. The fact is, that if one takes into consideration the whole social activity in which science consists, instead of confining attention to the logical relationship between formulas and their instances, it appears that the problem of understanding and justifying the procedures of the sciences is not at all the so-called problem of induction. Scientific work devises powerful techniques of research by the use of which people are able to make discoveries about processes hidden in the absence of such techniques, so that, having discovered such things, they can use them for their own purposes. The problem of understanding how this is done is not primarily a logical problem, though, of course, any problem concerning knowledge does involve logical considerations. It is a part of the more general problem of understanding how in conscious purpose of social activity men develop the human capacity of mastery over their environment. The positivist philosophy of science, which maintains that the sciences are concerned only with the order, combination and sequence of events within the field of sense experience, and that the conclusions of the sciences consist of laws enabling us to predict such experience, does not fit the sciences. Any survey of the whole field of activity, which constitutes scientific research, shows that that is not what the natural sciences in fact do. This philosophy results in a total misapprehension of what the natural sciences do, and of the real problem of how they do it. It did not arise from the development of the natural sciences themselves, but was foisted on them as an interpretation of their methods and findings, deduced from the philosophical doctrine that the object of knowledge is one's own sense impressions. From that doctrine, this philosophy of science followed. But on the other hand, the fact that this philosophy of science does not fit the natural sciences is one very good reason for questioning the philosophical doctrine from which it was derived. 5. Science and society. The big point which positivists always made in favor of their views is that they refuse to entertain the existence of anything not immediately open to observation. Everything that is supposedly hidden behind our sensations, as their real cause, as the objective reality not immediately open to inspection but which takes on a sensuous appearance, was ruled out as mysterious and unknowable. They persistently labored Berkeley's contention that the concept of the external material object, or matter, is the most abstract and incomprehensible of all other, with no distinct meaning annexed. As Mach forcibly expressed it, for us the world does not consist of mysterious entities. For the positivists, the world was just as it seemed. Everything they admitted to exist was always above board and open to view. The account which such a philosophy gave of the methods and achievements of the scientific investigation of nature did not fit the actual methods and achievements, though it could claim a specious plausibility for its account of the laws of nature. But it fitted in far better with the methods and postulates which were at the same time being adopted for the investigation of society. The development of the sciences, which came as an integral part of capitalist development as a whole, could not but lead to the conclusion that a scientific outlook must apply to society as well as to nature. Those who followed in the footsteps of Locke hoped to understand the workings of society in the same way as nature, by drawing conclusions from observation and experience, and they hoped to derive reliable principles for regulating social affairs, principles of ethics, of political economy, and of government, as conclusions from a naturalistic view of society. However, in the investigation of society, the desideratum was rather to take the phenomena of bourgeois society at their face value, as given facts of human nature, than to seek, as in the natural sciences, to penetrate behind the appearances to the operative causes which bring them into being and lead to their dissolution or transformation. As we have seen, Locke's contention that the object of our knowledge is our own sense impressions had already begun to suggest and to justify such an approach. From the very start of the bourgeois epoch, the study of economics was recognized as of fundamental importance for the practical understanding and government of human affairs, since material welfare and the accumulation of wealth depend on the proper workings of the economy. With the great increase of wealth in the forms of rent, interest and profit, the need was felt, as early as the middle of the 17th century, for understanding the mode of its production and distribution, and it was taken for granted that all wealth comes from labor. As Adam Smith put it at the beginning of The Wealth of Nations, the annual labor of every nation is the fund which originally supplies it with all the accessories and conveniences of life which it annually consumes. How the values produced by labor are maximized, and some returned to the laborers as wages and some appropriated by owners of land and capital, was the problem posed. Marx observed that with Adam Smith, political economy had developed into a single great aggregate, and to a certain extent the ground it covered had been deleted, but Adam Smith himself moves with great naivete in a continuous contradiction. On the one hand, he traces the interconnection between the economic categories, or the hidden structure of the bourgeois economic system. On the other hand, alongside this interconnection, he sets up also the connection, as it is manifested in the phenomena of competition, and therefore as it presents itself to the unscientific observer as well as to the man who is preoccupied and interested from a practical point of view in the process of bourgeois production. These two modes of approach in Adam Smith's work not only run unconstrainedly side by side, but are interwoven and continuously contradict each other, the one penetrating to the inner relations, the physiology, as it were, of the bourgeois system, the other only describing, cataloguing, expounding and bringing under classifying definitions the external phenomena of the process of everyday life in their outward manifestation and appearance. Here is of surplus value section on Adam Smith. Marx went on to say that this happened because Adam Smith's task was in fact a double one. On the one hand, to attempt to penetrate to the inner physiology of bourgeois society, on the other, to describe the living forms in which this inner physiology manifests itself outwardly, to show its relations as they appear on the surface. The one task interests him as much as the other, and as both proceed independently of the other, the result is a completely contradictory way of looking at things, one that expresses their intrinsic relations, the other, expressing the relations in their outward appearance. Marx himself was primarily interested, and in this his interest was analogous to that which inspired the great contemporary discoveries in the natural sciences, in what he here calls the hidden structure of the bourgeois economic system, or its physiology. The clue to this was provided by Ricardo's contention that, in Marx's words, Locke is the foundation, the starting point for the physiology of the bourgeois system, for the understanding of its internal organic coherence and life process, is the determination of value by labor time. In Capital, Marx took over Ricardo's contention that since what commodities have in communion is that they are produced by expenditure of human labor, the objective standard for the comparison of economic values consists of the quantity of labor, and working from this starting point, he was able to uncover the secret of the capitalist appropriation of surplus values and of the accumulation of capital. The capitalist mode of production was revealed as a historically constituted method of the exploitation of labor, and from this Marx was able to demonstrate how in capitalist conditions surplus value is appropriated in the various forms of rent, interest and profit, how wages, costs of production, prices, rates of profit and interest, etc., are determined, how forms of government reflect economic conditions, how the organization and class struggle of the working people develops. Writing to Engels, Marx said that thus we have arrived at the forms of appearance which serve as the starting point in the vulgar conception, ground rent from the earth, profit, interest, from capital, wages from labor. But from our point of view the thing is now seen differently. The apparent movement is explained of course, as Marx pointed out in the preface to Capital. The kind of techniques employed in the natural sciences are inapplicable in the scientific investigation of society, which requires to develop its own special methods. Neither microscopes nor chemical reagents are of use. The force of abstraction must replace both. The method is not experimental but analytic. By means of his method of analysis, Marx succeeding in achieving in social science what the natural sciences achieve, namely, explaining the immediately observed or apparent phenomena in economic, i.e., wages, rents, profits, rates of interest, price variations, etc., from the more fundamental, but nevertheless empirically discoverable and verifiable, processes and relationships by which they are determined. By this means he demonstrated, not that the capitalist system can be made to work well and to last forever, but that it is essentially an unstable and temporary social form of Cheyenne. His scientific theory became a practical program of action for the working class struggle against capital and for socialism. 6. Positivism, methodology for social science. Marx had observed, theories of surplus value, that Ricardo was already, as early as 1848, being repudiated by other economists. Ricardo discovers and proclaims the economic contradiction between the classes, as shown by the intrinsic relations, and hence the historical struggle and process of development is grasped at its roots and disclosed in economic science. The American economist ch3 already therefore denounces him as the father of communism. Mr. Ricardo's system is one of discords. Its whole tendency is to the production of hostility among classes and nations. His book is the true manual of the demagogue. The consequences of the labor theory of value and of Marx's ensuing investigation of the physiology of the bourgeois economic system proved quite unacceptable, and that theory, with all its works and consequences, was and has continued to be repudiated, on the grounds, directly taken from the positivist philosophy, that the whole idea of real value and its objective measurement is a metaphysical invention. Instead, it was asserted that science should stick to the observed facts, and so what Marx had called the second side of Adam Smith's field of interest became, and has continued to be, the exclusive field of recognized bourgeois economic and social theory, describing, cataloging, expounding and bringing under classifying definitions the external phenomena of the process of everyday life in their outward manifestation and appearance. Bourgeois economic theory studied to formulate laws connecting such observational variables as supply and demand, costs of production, wages, prices, rents, rates of interest, etc. This conception of law was precisely that formulated in the positivist philosophy, and the task which bourgeois economic theory set itself was precisely the task allotted to science by the positivist philosophy. In the 19th century, bourgeois economic theory was closely associated with the practical doctrine of laissez-faire. While economic theory formulated the laws, the practical doctrine proclaimed that these laws should be let operate without interference, and that the result would be the maximum benefit all round. At the same time, other elements of the positivist philosophy were employed for formulating the naturalistic doctrine of ethics known as utilitarianism, which might be described as the morals of laissez-faire economics. The premise of utilitarianism was the supposed fact that people always seek pleasure and avoid pain. From this, Jeremy Bentham concluded that pleasure is the only good, and that what people ought to do is always that action which will contribute to the greatest possible sum of pleasures, or, as it was expressed, to the greatest happiness of the greatest number. He concluded, secondly, that the duty of government is to promote the greatest good by regulating people's actions by rewards and punishments. However, people should be left to their own devices as much as possible, and be regulated and restrained only when strictly necessary to prevent them from injuring others. The actual conduct recommended by these conclusions might have been in doubt, but for Bentham's tacit assumption that the free development of private profit making contributes most to the public good by promoting the greatest attainable sum of satisfactions, so that private trade and industry should always be allowed full rein, and whatever hinders them severely discouraged. By means of this doctrine of ethics, there was worked out by Bentham a most active system of doing exactly what Hume had said could not be done, deducing what people ought to do from alleged empirical facts, above all, facts of economics. The whole stress was laid on that side only of Hume's contention, which stated that ethics could not be derived from knowledge of the will of God, or from any transcendental principles. Instead, morality was made a matter of empirical calculation of the supposed effects of actions, allegedly on the sum of pleasures, in practice on the pursuit of private profit. Laissez-faire became a thing of the past in the 20th century, with the development, foreshadowed by Marx, of competitive into monopoly capitalism. Government became the tool of the great monopolies, and government intervention in economic affairs became more and more expedient for them. At the same time, the formal theory of what Marx called vulgar bourgeois political economy, that the free operation of economic laws would produce full employment and continuous expansion, could not stand up in the face of experience to the contrary. Government intervention in economic affairs became imperative, social services had to be instituted, economic levers had to be manipulated, and economic theories reformulated accordingly. However, the basic procedure of bourgeois economic science remained the same, ignoring the hidden structure, studying the external phenomena. Very elaborate methods of fact-finding, statistical correlation, etc., were developed in the course of this study, and these methods have been very widely extended outside the narrow field of economic processes, to embrace sociological phenomena generally. The result is a very imprecise body of descriptive knowledge, but it is social science only in the sense defined by the positivist philosophy of science, not in the sense that it reveals the objective structure and movement of human society in its historical development. Accordingly, it serves the turn of those who, as Marx said long ago of Adam Smith, are preoccupied and interested from a practical point of view in the process of bourgeois production, who accept the system and do not wish to see beyond it, but not of those who want to understand how to change it, and to emancipate mankind from exploitation. For that purpose more than merely descriptive science is required, just as more than merely descriptive science is required for mastery of nature. The positivist philosophy of science was, then, in its actual development the philosophy WWCH enunciated the principles of the methodology of bourgeois social science, that science confines itself to describing, cataloging, expounding and bringing under classifying definitions the external phenomena of the process of everyday life, and to formulating laws correlating the data of observation. The positivist philosophy proclaimed that this is exactly what all science is called upon to do, and that it cannot do more. And so it also provided canons of criticism of the Marxist science of society, as a metaphysical invention, and of communism, as a dangerous conspiracy of deluded underdogs seeking to disrupt the social order and establish themselves in power in the name of mere doctrinaire schemes and utopian imaginings. Most of the effort of positivist philosophers went into the interpretation of the natural sciences, and especially of physics. It was presented as a philosophy of natural rather than of social science. This meant, in effect, that what was being done was to misrepresent the methods and findings of the natural sciences in such a way as to represent the officially recognized social sciences as practicing the same scientific method, and to represent scientific socialism as unscientific. It does not seem likely that the misinterpretation of the natural sciences could have become so persistent, or gained so much social prestige, had it not been for this evident, but never stated, service which positivist philosophy performed for bourgeois social ideology. At the same time, the positivist philosophy continued, as with its precursors in 18th-century British empiricism, to serve wider ends as well. Insofar as the stress was laid on the positive functions of scientific investigation, the effect was to bolster up bourgeois views about the social system and its workings. But insofar as stress could be laid, on the contrary, on the limitations of scientific knowledge, which, after all, revealed nothing but laws of combination and sequence of sense impressions, the effect was to stress the inadequacy of mere scientific modes of knowledge, and to leave scope for religious dogma, faith and, indeed, every kind of obscurantist authority, to stake a claim for recognition as essential elements in human consciousness, which supplement but do not conflict with the findings of the sciences. Chapter 4,